This is lesson 3 and this is called Balancing Act, and this is all to do with your balance when you're on your trampoline and what affects your balance, and then a position in your body called the centre of gravity, or the position in an object. So you can see here there's a picture of a girl standing on a balance board for a Nintendo Wii, and you may be familiar with this if you have one already. The Nintendo Wii will, if you stand on the balance board, will calculate where your centre of gravity is. So in our bodies, and in any body, every single molecule has got a mass and therefore has a weight. And every weight then is a force and that acts downwards. But our bodies and all bodies behave a little bit more strangely than that. And they behave as if there's a position in our body where we can balance perfectly on, and it's called the centre of gravity. Now, the definition of the centre of gravity is this. The centre of gravity is the point of an object about which the whole weight of the object appears to act. So the point of an object about which the whole weight of the object appears to act. Now, we actually know that the weight of the object acts everywhere in the object, that every molecule in the object has got its own weight, but this is a point about which the weight appears to act. So you then did an experiment to find the centre of gravity of an object. Just go out a wee bit again. And that experiment involved you taking a piece of card and hanging it up. So when you take a piece of card and hang it up, you put a pinhole through the edge of it and you make sure that it's able to move quite freely about that point. And then we take a line with a weight in the end, and the weight always acts towards the centre of the earth. We call that line a plumb line. Plumbers and builders used to use it to find a vertical line because a weight always acts towards the centre of the earth. So the line between the weight and your hand was always vertical. So they used to use it to make sure that the sides of their buildings were vertical. And it will hang towards the centre of the earth, and you mark a line along your card and behind the plumb line. And then you take out your pin and off your plumb line and you hang it up by a different corner. Maybe say this corner, and you do exactly the same thing again. And whenever you do this, if I just turn this round, you can see that if there was a plumb line on the end of it, it would hang down this direction. The place where the two lines cross is the centre of gravity. And when you did this, if you took that piece of card and you put your finger underneath it, your piece of card should have balanced on it, whether it was a nice regular shape like this or not. And that's where your centre of gravity is found. Now, regular objects have a very definite centre of gravity, and that generally is where you have at least two lines of symmetry, where the lines are crossing. And so if you have a wee look at this, I'm just going to draw this roughly in pencil. You could see the two lines of symmetry would cross along here. In fact, I'll maybe just do this properly. I'll draw along a pen here. So there's one, and there's a second there, and so therefore your centre of gravity is this point here. This one here is similar, another nice regular shape. If you draw from one place across to another, then in the centre of that you're going to have your centre of gravity. This is another shape here, similar idea. If you draw across from one corner to another, all those lines should pass through the centre of gravity. So we could draw them anywhere really, and that place there is the centre of gravity. Now, I put this one here in just to make you have a wee think about this. A very odd thing happens if there's a space in the middle of the object. And so if I took this and drew down along down through the centre of this and across through the centre then too. A very odd thing happens. The two lines cross in the very middle, which is actually in the hole. So that means that in that object we couldn't hold your finger in underneath that object and expect it to balance on your finger, because the centre of gravity is actually in the hole, very strangely. And that's what happens with a polament. A polament centre of gravity is the middle of the hole. So that couldn't be balanced on a fine pinpoint, not in the centre anyway. Now, the next little bit then is how to make an object more stable, or even more importantly, how to make yourself more stable. So this is a rugby player here, and he's standing on the ground. And whenever he has his legs a little wider apart there, that makes him more stable. So if there was going to be, say, another rugby player tackling him, he's far more stable because he's got his legs wide apart like this. So we say whenever he does that, that's the width of his base, from the edge of one foot to the edge of the other. And in terms of his base, if you look at his base there compared to his base there, you should be able to see that this man here is much more stable because his base is wider. And you should know yourself, if you're standing on the bus and the bus kind of moves suddenly, to make yourself more stable, you will move your legs wider apart. Or to make yourself more stable in another situation where you might fall over, you'll do something like that. And we do this naturally without even really knowing what we're doing. So that's one way of making yourself more stable, by making the base wider. This girl here isn't very stable at all. She has a very, very good sense of balance, obviously, because the width of her base is only the width of her foot there. I don't know if you can see that. I'll maybe scan in on her a little bit. You can see there's her foot standing on the board. The rest of her weight there is all above, and the only bit of her base, which is touching the ground, is the width of her foot. So she's quite unstable. It wouldn't take very much at all to push her over. And you might be able to see there her legs kind of at an angle, so she's leaning very slightly to this side to try and make sure that she stays as stable as possible. Now, another thing that we would like to do here is that if we can try and make sure that our centre of gravity is over our base, then we will stay stable in the position that we're in. Our centre of gravity is roughly about 8 centimetres below our belly button, for most people anyway. And so the centre of gravity for this person here, and I'll just do this in green, the centre of gravity for this person here is probably about there. And you can see if I draw a line down from his centre of gravity, you can see that that line's passing through the base. So his centre of gravity is over his base and he's stable. He's even more stable here. Again, if I draw from his belly button down, you can see it definitely passes very, very well within his base, this line. And it would take quite a lot for somebody to push him over enough so the line doesn't pass through his base. So he's really quite stable. The girl's quite unstable. Her centre of gravity, again, would be about here, but she is leaning over. And so whenever she leans over, she has just about got her centre of gravity passing through her base. And that's why she's staying stable there. It would take very, very little movement for her to fall over, because this line, once it passes outside the base, over she goes. So there are two ways to make an object more stable. We've mentioned one of them there, and that is to have a wider base. And the second one is to lower our centre of gravity. Now, we can't do that easily when we're standing upright, but what we can do is we could crouch down, we could lie down. All those things will make our centre of gravity lower, and of course when you lie down, your base then is the whole length of your body, length and width, the whole area that's touching the ground, and so that makes you very, very stable when you lie down. When you stand up, we're relying on the width of our feet, and that's our base. And that's why I suppose it takes a good while before babies can learn to walk, because they have to learn to keep their centre of gravity over their base when they're walking. It's also the reason why children will be very stable whenever they're skiing compared to adults, because children have a very low centre of gravity compared to adults, and therefore they're much more stable than adults. So you can have a wider base or lower your centre of gravity. And to lower your centre of gravity, you either make yourself shorter, or what you could do is you could add more weight to your bottom half, or to your feet, or to your legs, or whatever. And the last wee slide here just is a wee question, stable or not. So you can see, first of all, the gymnast. Have we look at her? This is a gymnast. She's on a beam. The beam is only 4 inches wide, and 4 inches is 10 centimetres. So it's very, very thin, which is only maybe, it's probably not the length of that pen. Just go out a bit. 10 centimetres is maybe from there to there. So that's the width of the beam. That's very, very short. And it's very difficult for her to keep her centre of gravity. It's called centre of mass here, but it's the same thing. Her centre of gravity over her base. Her base is her hands here on the beam. And her base when she's standing here is her feet on the beam. But she can't have a base any wider than the beam itself. And so it's very, very difficult to balance on the beam. In this case, she is stable because her centre of gravity is passing down through the base, and that's fine. In this case here, she's about to fall over unless she can compensate and produce a restoring, what we call, moment to get herself upright again. And that's why she's got her hands out, to try and pull her weight over this direction a little bit, so that this line here, instead of passing outside of her base as it is, will pass down through her foot again, and then she becomes stable. So in some cases you can get enough restoring moment from doing something like putting your hands out to restore yourself back to a stable position. But in this case, it looks like our gymnast here, I'm afraid, is just going to fall over. And the reason is because her centre of gravity has passed outside her base. The next wee diagram here shows 2 tractors. One of them is fairly short and the other one is tall. So the tall one, its centre of gravity is higher because it's got more weight higher up. And this would be the same, like a tall vase would have more weight higher up, and it would generally be more unstable. So you can see in these 2 cases, the 2 tractors are in flat ground, and they're both quite stable because their centre of gravity passes down through their base in both cases. You can see there, and that's no problem. There's the base for that one and the base for that one, and so there's no problem there. But the problem does happen whenever you go on to sloped ground. And you can see there, this is a short tractor, centre of gravity. When you draw the line down, you can see that it still passes within the edge of the base there, outside of the wheels. But in this case, this one here is in trouble because the centre of gravity is higher. When you draw the line down, it passes well outside the base, and that tractor is going to fall over. There's what we call a moment pulling it over this direction, and so it's going to fall over, and unfortunately there's nothing you can do about that.